Algebra 2, Unit 8, Lesson 2. And in this section, we're going to talk about finding zeros of any polynomial function. And in this, we're going to use synthetic division, which is a skill we learned earlier in the year. And synthetic division will help us find all the factors of a polynomial equation fairly easily. Sometimes, depending on what the roots are, these can get a little difficult. But I'm going to show you a way to generate a list of possible things that might work. Rather than just picking random numbers from thin air, you can only pick numbers from this list. If it has any factors that will work, they will have to come from the list that we're going to generate. So that's what we're going to do first. And to do that, we're going to use something called the rational zeros theorem. I call that the P over Q theorem. And basically what that is you're going to take your P values. Now, your P number is the constant, okay? And what I'm going to do is I'm going to find all the factors of my P value or my constant. So, the factors of my P, the P value is 9. Factors of 9 are 1, 3, and 9. Then I'm going to find all the factors of my Q value. My Q value is the leading coefficient, okay? So my leading coefficient here is 2. So my Q values here, since my leading coefficient is 2, are the factors of 2. So for my Q values, I'm going to put factors of 2, which are just 1 and 2. Now, for my P over Q values, the values that could possibly be factors of the polynomial I'm looking for are all the values where I'm putting P over Q. So my P over Q values would be 1 over 1, which is 1, 1 over 2, or 1/2, 3 over 1, which is 3, 3 over 2, or 3/2, 9 over 1, which is 9, and 9 over 2, which is 9/2. And then I'm going to think about the positive and negative of each of these numbers. So I'm going to put a plus minus in front of each of these. These are not answers. These are not the roots. Remember, looking at the leading coefficient here, we know this one's going to have 3 roots. Well, look at how many numbers we have here. We have 12 numbers total if you talk about the positive and negative. So there's only going to be a possibility of having 3 of those numbers work. And we could still have some roots that are imaginary. So we're not sure yet whether 3 of these numbers work or whether it might just be one of them and then you have 2 imaginary roots. We just don't know yet. So what we're going to do is we're going to use this list that we generated to try to find factors or something, a number that goes into this evenly with a remainder of 0. And the easiest way to do that is to use synthetic division. So what I'm going to do is these would be the numbers that I'm going to put right here to see if it works. And I'm just going to go straight down the list. I'm going to try 1. If that doesn't work, I'm going to try -1. Then I'm going to try 1/2. If that doesn't work, I'll try -1/2 until I get one that works. Okay? So now, let's review synthetic division. For synthetic division, remember, we had to put the coefficients of each term down on this first line, and we have to make sure that if anything is missing, any of the terms are missing, we have to put 0 for those coefficients. This goes from the power of 3, 2, 1 to 0. So there are no coefficients missing. So I have a 2, a -11, a 12, and a 9. I'm going to leave a little space and draw a line, and I'm going to use 1 first. So I'm going to put 1 here, and I'm going to use synthetic division to see if it works. I'm going to bring down the 2. And remember, synthetic division, we do multiply, add, multiply, add, multiply, add till we get to the end. It is a factor if at the end we get a remainder of 0. So 1 times 2 is 2. We add these and get -9. 1 times -9 is -9. We add these and get 3. 1 times 3 is 3. We add those and get 12. It did not go in evenly. 1 is not a factor. So I'm going to go back. I'm going to leave my setup, and I'm going to put in -1. And I'm going to try it again. I bring down the 2. 2 times -1 is -2. Add those together, I get -13. -1 times -13 is 13. I add those together, I get 25. That's going to give me a -25. That does not work. So -1 didn't work. Next on the list is 1/2. So I'm going to try 1/2. I bring down the 2. 2 times 1/2 is 1. -11 plus 1 is -10. 1/2 times -10 is -5. 12 plus -5 is 7. 1/2 times 7 is 7/2. That's not the same. It is not going to be a factor. Next on the list is negative 1/2. Bring down to 2. Negative 1/2 times 2 is negative 1. I add those together, I get negative 12. Negative 1/2 times negative 12 is 6. I add those together, I get 18. Negative 1/2 times 18 is negative 9. I add those together, I get 0. Negative 1/2 is a factor because it went in evenly with no remainder. So once I've done that, remember, I need to write the depressed polynomial. And remember, to do that, the degree of the x term, the beginning, goes down by 1. So this would be 2x squared minus 12x plus 18. I set that equal to 0. I'm going to factor it to get my other two roots. Because once I get it down to an x squared, I can either use factoring or the quadratic formula for every single one that's an x squared power. So that makes it nice. Once you find one with synthetic division, if it's a degree of 3, then we might not have to do it anymore. Another thing that I would always try, and I didn't bring this up earlier, if it's or if you have 4 different parts to the polynomial that you're trying to find, I would try to factor by grouping first to see if it works. Because factoring by grouping, if it works, will save you the amount of time that it takes to do all this. This one though, if I factor that by grouping, or if I try to, and I bring out an x squared, I'd have 2x minus 11, and here I could bring out a 3, and that would give me a 4x plus 3. So these factors don't match. So factoring by grouping wouldn't have worked there anyway. So that's not going to be something that is even an option for me at this point. But now, once I get this, I've got a polynomial equation that I can maybe factor. Now, if you look at this, 2, 12, 18, all of those are divisible by 2. So to make this factoring easier, I'm going to go ahead and divide everything by 2 to get rid of that. So that leaves me with x squared minus 6x plus 9 equals 0, and then I'm going to factor that. Are there factors of 9 that I had to give you 6? 3 and 3. So I'm going to put a 3 and a 3. The plus tells me they're both the same as that sign, so they're both minus, and we get 0. So we have x equals 3 and x equals 3. Now you might say, well, that's only one more root. No, it's 2. It's a double root. Remember, that's okay to have a double root. Remember, what did we say happened to the graph when that happens? Didn't we say that on the graph, I'll just put a little one right here. On the graph, we're going to have at 3 a parabola looking thing that touches the graph either that direction or it touches the graph in that direction. It touches the graph at that one spot, but it doesn't cross through. So a double root, that's what happens in the graph. And all of this will be significant when we get into the graphing of these polynomial functions. First thing we'll always have to do, though, is find all the roots. And we've learned how to do that. Now, we would expect this to have 3 roots. It did. It had negative 1/2, and it had 3 and 3, double root. Looking at the next one, it says x to the 5th minus x to the 4th plus 13x cubed minus 13x squared plus 36x minus 36 equals 0. How many roots would we expect this one to have? Well, if you look at that, we would expect it to have 5 roots. So this one is going to be a little bit more difficult. Let's talk about our p over q. Remember, the p values are the factors of the 36. Well, if I think about that, I've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So 1, 2, 3, 4, 6, 9, 12, 18, and 36 are my factors of 36. My q's are the factors of 1 because the leading coefficient is 1 there. So wouldn't this list be my p over q's? Which is nice because we don't have any fractions involved. So my p over q list is going to be this list generated again with plus minus in front of them, because it could be plus or minus any of those roots. And so for this one, let's just try 1, negative 1, and then we'll go from there. The coefficients here are 1, negative 1, 13, negative 13, 36, and negative 36. So I left a little space. I'm going to bring down the 1. 1 times 1 is 1. That gives me 0. 1 times 0 is 0. That gives me 13. 1 times 13 is 13. So that gives me a 0 when I add. 1 times 0 is 0, giving me 36. And 1 times 36 is 36, giving me a 0. So 1 went in, that's nice. The first number we picked went in. That makes it very nice for us. Then I have to write down my depressed polynomial. Remember, the depressed polynomial goes down by 1 degree. So I have 1 x to the 4th plus 0x cubed plus 13x squared plus 0x plus 36. And that equals 0. Now, looking at this, I could go through, do synthetic division again right underneath there with other numbers. But if I look at this, that's x to the fourth. The middle term is x squared. I'm thinking I might be able to factor this using the method we learned in the last section. Or, well, we learned it earlier, but we did a couple of these in the last section. So the middle term is x squared. That means these are both x squared. Are there factors of 36 that add to give you 13? Well, I'm thinking 9 and 4. The plus tells me these are both pluses. And so now I can set each of those factors equal to 0. So x squared equals negative 9 and x squared equals negative 4. I put in the square root, so that means I'm going to have a plus minus in front of all my answers. So I have x equals plus and minus 3i because it's a negative underneath the square root. And over here I have x equals plus and minus 2i. So that's my 5 roots. I've got 1 plus and minus 3i plus and minus 2i. So I have 5 roots for this equation. It's important in a problem like this for you to see how this works when you've got a lot of different coefficients and synthetic division. But I also want to point out with this one, we could probably factor by grouping if you recognize that it would work. And so I want to show you that we'll get the same answer, doing it a little bit differently. But normally, most of the time when we have something with this many terms, factoring by grouping doesn't work. This one just happens to be a fairly simple problem. If I factor this by grouping, instead of having 2 groups, I'm going to have 3 different groups. Now, before each of my groups, I have to have a plus. If I didn't have a plus, I would have to make this plus a negative, right, if it was a minus. But those were all pluses, so I don't have to change any answers. Then I'm going to take out what each group has in common. Looking at this one, I can bring out an x to the fourth. That leaves me with an x minus 1. In this one, I can bring out a positive 13, x squared. And when I do that, that leaves me with an x minus 1. In this one, I can bring out a positive 36, which leaves me with an x minus 1. Then, looking at this, that's the first term, there's the second term, there's the third term. Is there anything they all 3 have in common? Hopefully you're looking at that saying yes, an x minus 1. So I can bring an x minus 1 out of all 3 of those terms, leaving me with x to the fourth plus 13x squared plus 36 equals 0. At this point, I set each of them equal to 0. That's x equals 1. For this one, I can factor. Same factors as before. So I have x squared equals negative 9, x squared equals negative 4. Take the square root, I'll have x equals plus minus 3i. And take the square root here, I have x equals plus minus 2i. So same answers, did it a different way. There are going to be some times where you have different ways that you can do the problem. You might do it different than somebody else in the class and get the same answers. That's fine. We want to have as many options as possible so that you can pick the one that's easiest for you and get the right answers every time. Here's another one. I'm going to go ahead and tell you factoring by grouping will not work. If we take an x squared out here, we have an x minus 2. Nothing comes out of these two. So factoring by grouping is not going to work. So we're going to have to use the P over Q method. The P values here, the factors of 20, that would be 1, 20, 2, and 10, 4, and 5. The Q values are 1, and then the P over Q's would be all of these numbers with plus minus in front. Now, knowing what your P over Q values are, go ahead and try to finish this one on your own. Set up your synthetic division. See if you can get a number that works. Once you get one number that works, you should be able to set it up and either use factoring or the quadratic formula for the answers. So here are the answers. The roots are x equals 1, x equals negative 4, and x equals 5. This one was not too bad because the first number I picked worked. And that's always nice when that happens. So 1 went in with a 0 remainder. Then I took the depressed polynomial and I factored it, factors of 20 that subtract give me 1 or 4 and 5. And using the signs, I was able to find my 3 roots fairly easily. Remember, this tells us we have 3 roots. That's how many we found. We know we found all of them. So that's all we need to do for this problem.